Hello friends, I welcome you on my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss examples on second case of chain rule which we have discussed in previous lecture. So we start with example number 1. If u is function of xyz given by u equal to x raised to 4y plus y square z cube, where x, y, z are functions of r s t as given by x equal to r s e raised to t, y equal to r s square e raised to minus t, and z equal to r square s sin t. Then we are asked to find the value of partial derivative of u with respect to s when r equal to 2, s equal to 1 and t equal to 0. So here u is function of x, y, z. U is directly function of x, y, z, and x, y, z all are functions of r, s and t. So u is indirectly function of r, s, t, or we can say that u is composite function of r, s, t. So to find out partial derivative of u with respect to s, we apply chain rule. So because u is directly function of x, y, z, to find out partial derivative of u with respect to s, first we differentiate u with respect to x, y, z. So first we write down partial derivatives of u with respect to x, y and z, and in the product we will write partial derivatives of x, y, z with respect to variable s, del z by del s. So here we are asked to find out partial derivative of u with respect to s. So first we differentiate u with respect to x, y, z because u is directly function of x, y, z, and in the product we write partial derivatives of x, y, z with respect to s. Now we calculate all the partial derivatives and substitute here. If we want to find out del u by del x, we concentrate in the formula for u. So when we find out del u by del x, we consider y and z as constant. So derivative of these terms is 0, and here y as it is, derivative of x raised to 4 is 4x cube. So del u by del x is 4x cube times y. Y as it is, derivative of x raised to 4 is 4x cube. And in the product we have partial derivative of x with respect to s. So we consider r and e raised to t as constant, and derivative of s is 1. So here we write r into e raised to t plus partial derivative of u with respect to y. So in the first term x raised to 4 is constant, derivative of y is 1. So x raised to 4 as it is, derivative of y is 1. In the second term z cube is constant, derivative of y square is 2y. So it becomes 2yz cube. So here we add 2yz cube. In the product we write partial derivative of y with respect to s. So this is the formula for y. Here we are differentiating with respect to s. So r and e raised to minus t constant, derivative of s square is 2s. So it is going to be 2rs e raised to minus t plus del u by del z. So we again come here derivative is with respect to z, so first term becomes constant, its derivative is 0, and in the second term y square is constant, derivative of z cube is 3z square, so it becomes 3y square z square. So plus 3y square into z square, and derivative of z with respect to s. So in the formula for z, r square is constant, sin t is constant, derivative of s is 1. So r square into sin t. So this is partial derivative of u with respect to s. Now we are asked to find out value of this derivative del u by del s at r equal to 2, s equal to 1 and t equal to 0. So first we calculate values of all these derivatives, or first we calculate values of x, y, z at r equal to 2, s equal to 1 and t equal to 0. Because when we put del u by del s, when we substitute r equal to 2, s equal to 1, t equal to 0 in this expression, we have here terms containing x, y, z, and x, y, z are functions of r, s, t. So we have to put values of x, y, z at r equal to 2, s equal to 1 and t equal to 0. So first we give this number 1 and we find out values of x, y, z at r equal to 2. So we write at r equal to 2, s is 1 and t is 0. So r equal to 2, s equal to 1, t equal to 0. At these values of r, s, t, first we calculate what is x. So x is given by r, s, e raised to t. So r, s is 1 and e raised to t means e raised to 0. So value of x is 2. Y is given by r s square e raised to minus t. Y equal to r s square e raised to minus t. So we put r equal to 2, s square means 1 square e raised to minus 0. So this is 2 into 1 into e raised to 0, that is 2. And then z is given by r square s sin t. Z equal to r square s sin t. So we put z equal to r square means 2 square, s means 1, sin t means sin 0. And as we know, sin 0 is 0, so it becomes 0. So these are the values of x, y, z at r equal to 2, s equal to 1, t equal to 0. So now by 1 we find out value of del u by del s at r equal to 2, s equal to 1, t equal to 0. Del u by del s equal to, so now here we will substitute values of x, y, z at r equal to 2, s equal to 1, t equal to 0. So here in the first term we have x cube into y and 4. So value of x is 2 and value of y is 2 at these values of r, s, t. So we put x equal to 2 and y equal to 2. So it is 4x cube. So x is 2 and y is also 2. Now in the product we have r into e raised to t. So r is 2 and t is 0. So in the product we have r into e raised to t. So we put r equal to 2, t equal to 0. Plus x raised to 4 plus 2yz cube. So x raised to 4 means 2 raised to 4 plus 2y, y is 2 and z cube, z is 0. So it is 0. X raised to 4 plus 2yz cube. And in the product we have 2rs e raised to minus t. So we substitute values of r, s, t. 2r is 2rs. In the product we have 2rs e raised to minus t. So 2 into r into s into e raised to minus t, that is e raised to 0. Now in the third term we have 3y square z square. So z is 0. So we can directly put 0, or we write down 3y square into z square, that is 0 square. And in the product we have r square sin t. R is 2 and t is 0. So r square is 2 square sin 0. So now we simplify this and we check what we obtain for del u by del s. So this is going to be 4 into 8, 32. Okay, we write down this. This is 4 into 8 into 2, that is 8 into 8, 64. So we obtain 64 into 2 plus, this is going to be 0, and here we have 2 raised to 4, which is 16. Here e raised to 0 becomes 1, so this is 4. And because sin 0 is 0, this is 0, we have 0 here. So therefore del u by del s is, here we can consider this as, this is going to be 128 plus 64, and if we add 2, we obtain 128 plus 64, that is 192. So this is the value of del u by del s at r equal to 2, s equal to 1 and t equal to 0, 192. So in this way we can use chain rule to calculate this type of partial derivatives. We consider another example. It is given that u is function of x minus y, y minus z, z minus x, and we have to show that sum of partial derivatives of u with respect to x, y, z is 0. Now here it is not given that what is this function f. It is given that u is arbitrary function of x minus y, y minus z and z minus x. So here first we will assume that this x minus y, let x minus y is denoted by say small r, y minus z is denoted by small s, and z minus x is denoted by t. Then we can write u as a function of r s t. So now u is a function of r s t, and r s t are functions of x, y, z. So u is directly function of r s t and indirectly it is function of x, y, z. So to find out all these partial derivatives we can use chain rule. So by chain rule, if we want to find out del u by del x, then because u is directly function of r s t, first we differentiate u with respect to r, s and t. Del u by del r, del u by del s, del u by del t. U is directly function of r s t, so first we differentiate u with respect to r s t. Now we are interested in the derivative with respect to x. So in the product we write down partial derivatives of r s t with respect to x. Now we don't know what is function u, so we will keep these three derivatives as it is, and del r by del x, del s by del x, del t by del x can be obtained from these three formulas. So therefore del u by del x is del u by del r into del r by del x. So del r by del x is 1 plus del u by del s into del s by del x. So there is no x in the formula for s, so it becomes constant, derivative is 0, plus del u by del t into del t by del x. So it is going to be 0 minus 1, that is minus 1. So therefore del u by del x is del u by del r minus del u by del t. So we give this number 1. Similarly we find out remaining two partial derivatives again by chain rule. So now by chain rule, partial derivative of u with respect to y equal to, first we write down partial derivatives of u with respect to r s t, del u by del r, del u by del s, del u by del t, and in the product we differentiate r s t with respect to y. So here del s by del y and del t by del y. So therefore del u by del y equal to, we don't know what is u, so we keep del u by del r as it is. R is x minus y, s is y minus z, and t is z minus x. Let me check again, x minus y, y minus z, z minus x. So we can find out del r by del y. Here it is 0 minus 1, that is minus 1, plus del u by del s by del y is 1 minus 0, that is 1, plus del u by del t by del y is 0 because there is no y in the formula for function t. So therefore partial derivative of u with respect to y is minus del u by del r plus del u by del s. So we give this number 2, and again by chain rule we can find out del u by del z. So we write here again by chain rule, del u by del z is nothing but, first we differentiate u with respect to r, s and t, and in the product we write down partial derivatives of r, s, t with respect to z. So therefore partial derivative of u with respect to z, r is x minus y, so del r by del z is 0, plus del u by del s, s is y minus z, so del s by del z is minus 1, plus del u by del t, t is z minus x, so del t by del z is 1. So therefore del u by del z equal to 0 minus del u by del s plus del u by del t. So we give this number 3. So to find out addition of these three partial derivatives, we have to add equations 1, 2 and 3. So adding 1, 2 and 3, we obtain left hand side will be addition of del u by del x, del u by del y and del u by del z. Now if we concentrate on the right hand side, here in equation 1 we have del u by del r, so that will cancel out with this minus del u by del r. Similarly this is minus del u by del t, that will cancel out with this del u by del t, and this is minus del u by del s, that will cancel out with this del u by del s. So if we add right hand side of all these equations, we obtain 0. So we have shown that sum of all the partial derivatives of first order is 0 for a given function. So whenever you have this type of things, you start by assuming that these functions are given by some another RST, or you can use your own notations also, and then apply chain rule. You can easily do this type of problems. This is another problem of the same type. Here also u is function of x by y, y by z, z by x, and we have to show that x into del u by del x plus y into del u by del y plus z into del u by del z is 0. So we start by taking this x by y equal to say r, y by z equal to say s, and z by x equal to say t. Then u is a function of RST, and RST are functions of x, y, z. So we require x into del u by del x. So for that we first calculate what is del u by del x. So by chain rule, del u by del x, u is function of RST. So first we differentiate u with respect to RST. Del u by del r, del u by del s plus del u by del t. Now we are differentiating with respect to x. So in the product we consider partial derivatives of RST with respect to x. So therefore del u by del x equal to, we don't know what is u, so we keep del u by del r as it is. Del r by del x is obtained from this formula for r, because we are differentiating with respect to x. 1 by y is constant and derivative of x is 1. Del u by del s we keep as it is. Derivative of s with respect to x, so there is no x in s, so it becomes constant, therefore derivative is 0. Del u by del t as it is. Derivative of t with respect to x, so here z is constant and derivative of 1 by x is minus 1 by x square, so we have minus z divided by x square. Now here we require x into del u by del x, so we multiply both sides with x. So x into del u by del x equal to x by y del u by del r, this is going to be 0, and here if we multiply with x, 1x will cancel out, and we have minus z by x into del u by del t, so we give this number 1. Again we find out del u by del y using chain rule. So by chain rule, partial derivative of u with respect to y equal to, first we differentiate u with respect to RST. So del u by del r, del u by del s, del u by del t, and here derivative is with respect to r with respect to y, so we differentiate RST with respect to y. So therefore del u by del y becomes del u by del r as it is, del r by del y. So r is given by x by y, s is y by z, and t is z by x. So let me check x by y by z, and z by x. So partial derivative of r with respect to y is x as it is. Derivative of 1 by y is minus 1 by y square, so minus x upon y square, plus del u by del s by del y is 1 by z constant, derivative of y is 1, and plus del u by del t by del y, so there is no y in t, so derivative is 0. And here we have to multiply both sides with y, so we multiply both sides with y and we simplify. Here 1 y will cancel out, so we can write this as minus x by y del u by del r, and here y by z del u by del s, and this becomes 0. So we give this number 1, and at last we find out partial derivative of u with respect to z. Again we apply chain rule. U is function of r s t, so first we differentiate u with respect to r, s and t, and here we are interested in the derivative with respect to z, so we multiply with partial derivatives of r, s, t with respect to z, and then we substitute values of partial derivatives. U is unknown function, so we keep u as it is. Del r by del s, there is no s, sorry, I made a mistake here. Here I have to write z, so del r by del z, so there is no z in the formula for r, so it becomes constant. So derivative of r with respect to z is 0, plus del u by del s, derivative of s with respect to z, s is y by z, and we are differentiating with respect to z, so y is constant and derivative of 1 by z is minus 1 by z square, so del s by del z is minus 1 by z minus y by z square. Del u by del t as it is, and t is z by x, so 1 by x is constant, derivative of z is 1, and we multiply this both sides by z, so z into del u by del z, this going to be 0, and here 1 z will cancel out, and we have minus y by z del u by del s, plus we are multiplying with z, so this becomes z by x del u by del t, so we give this number 3. Now we have to show that addition of these three equations is 0, so first we write down. In the next step we have to add equations 1, 2 and 3, so adding 1, 2 and 3, left hand side is x del u by del x plus y del u by del y plus z del u by del z. Now we check whether the terms on the right hand side cancel each other or not. So we consider this one x by y del u by del r, so it will cancel out with minus x by y del u by del r. Now we find out what is minus z by x del u by del t, so whether we obtain z by x del u by del t or not, so it is there. And now we consider minus y by z del u by del s, so that will cancel out with y by z del u by del s. So all the terms on the right hand side cancel each other, therefore we obtain 0 as we wanted. So in this way we can use chain rule to prove this type of problems. So this is all about today's session. In the next lecture we will discuss some more examples on chain rule for partial derivatives. I hope you like this lecture. Thank you.